to talk about innovation and collaboration. And when I noticed that I'd been placed in the modeling and simulation department, that gave me some ideas. And I thought a good subtitle for this talk would be, if the mouse works, can better modeling and simulation improve project outcomes? And I thought about it, and I decided the answer was no. Because we're really interested in project outcomes. We're not actually interested in just simulating stuff. We want to get stuff built. Anyhow, then I thought about it a bit harder, and I decided that the answer was mostly no. So why do I think that? Well, let's look at how we implement an innovative transport project, like a PRT system. This is the formula that sort of became standard, I would say, in the industry. First, we use modular infrastructure that snaps together like Legos. That's an actual automated train in Lego. Then we drop it in with minimal disruption to the site, like SpaceX rocket there, and profit, yay, okay. So what role does modeling and simulation play in this process? Well, it's very important. We need to determine the travel time, capacity, and ridership of the city, of the system. That gives us our benefit. We need to determine the track length, the fleet, and the station sizing. That gives us our cost. And then we make a business case which consists of benefit minus cost. Now, this approach to building innovative transport systems has been spectacularly unsuccessful. I don't know of a single system that's actually been built with this business case. If you look at the systems in Heathrow and Masdar and so forth, they were built for other reasons, not because of this. So if this doesn't work, then what is the role of modeling and simulation? Well, to answer that question, I thought I would misappropriate a bunch of frameworks from sociology and psychology. So, and first, let's look at how a conventional transport system actually gets built. So this is a successful project, the Portland Orange Line, which opened last year. It's a 12-kilometer corridor, bidirectional. It's 17 stations, and it cost $1.5 billion. So that has pretty much the opposite business case of what we were just looking at. But somehow this worked. Why did this work? Well, let's follow the money. Where does it get spent? About 30% of that money gets spent on stuff you would recognize as infrastructure. That's tracks, stations, signaling systems, maintenance yards, and so forth, rolling stock, etc. That's only about 30% of the project budget. About 20% of the budget is finance, and that's just has a nasty way of multiplying, and then fully 50% of the budget is this other stuff. What is that other stuff? Does it matter? What does it have to do with modeling and simulation? Well, that's where I misappropriate the frameworks. So we're going to start with the hierarchy of needs. Every infrastructure project has a hierarchy of needs, starting with physical needs. It needs to fit the site. And this matters to a lot of people. It matters to property owners nearby. It matters to planners and civil engineers, geotechnical engineers. It matters to manufacturers and quantity surveyors and financiers, because how the infrastructure fits the site really adds up. You know, if it's sort of a pathway off to the side, or if it's a tunnel, makes a big difference. It matters to policymakers because they need to see evidence of buy-in from all of the above. So policymakers, a theme of this presentation is that policymakers don't actually know anything. They look around to see if everybody else is nodding their head, and then they do the same. But they need to see these people nodding their heads. So when do you need to worry about this physical fitness of your infrastructure project? Before you simulate. Why is that? Because if you're coming in looking at a map, it's really easy to think, I'll connect these destinations like this. And then you build a business case around that, and you do a whole bunch of work, and then you go out and take a survey of the site, and it turns out they need to be connected like that. This will change all of your assumptions, and this happens way more often than you'd like to think, unless you're building on a greenfield site in Kansas, in which case you might be able to do it. But if you're building on a site with a 2% slope or a single building on it, it's going to be more like the bottom one. So you need to figure out your physical fit, or you don't have a project. After physical fit is safety. If you don't have a safe system, you don't have a project. Now, how do you convince people of safety? Well, you've got to make a safety case, you've got to have independent auditors, you've got to do scenarios with the fire departments and police and civil defense and so forth. You have to run through the whole thing with the transport operators in the area, and there's a little bit of a role for simulation here, but not a tremendous role. Again, policymakers, to be convinced it's safe, need to look around the room and make sure everybody else is nodding their heads. Beyond safety, there's belonging. What does that mean? So the system needs to belong where you're putting it. If you're putting it into a community, it needs to feel like it's a part of that community. If you're putting it into an airport, it needs to feel like it's part of the business case and the brand of that airport. If it is disrupting the existing social fabric or operational fabric of the people that you're putting it in with, you have a real problem. So you need to work with those people to convince them that this is actually fitting with what they've got. And that's that's neighbors, that's special interest groups, that's, again, the transport operators and so forth. Now, simulation is starting to have a role, but only to the degree which it drives outputs that all of these people need to see. So neighbors of your project, they don't care about simulation, they do care about visualization, though, because that's how they're thinking, and that's where experiential simulation really matters. The actual simulation numbers matter less to the neighbors, but the visualization of it does. For transport operators, they'll be very, very concerned with simulation, actually, but they'll only be concerned in a multimodal context. They want to know how your system is going to affect their system. So if you can't do a multimodal simulation, you'll have a problem. Moreover, a lot of transport operators will actually be attached to their own simulation systems. They've got a system they're familiar with, they know how to simulate stuff on it, they want to simulate on their system. You coming in with another simulation that they can't talk to or tweak the parameters of doesn't necessarily do a lot of good. But you need to get them on board if you're going to get the sort of social fit of this project. Now, if you get through these three tiers of the pyramid, then, come on, button. Then to misappropriate another framework, what you've done is you've satisfied the hygiene factors for the project. Now, hygiene factors are from this theory of motivation, which is basically management theory's way of saying that the opposite of love isn't hate, it's apathy, right? So if you can convince people that this project will fit in physically, that it will be safe, that it will fit in, that it will belong within its context, then they won't hate it anymore. But they could still be apathetic about it. They're not going to love it. So you need to move beyond a lack of hate to actually embracing the project that you're trying to create. And you need to motivate them, get them in the upper right quadrant there. How do you do that? Well, move on to Esteem. And what does that mean? It means, does this enhance the community, or does this enhance the airport or the business park or wherever else we're putting it? Is it taking what we're doing and it actually not just not messing it up, but actually making it better? Now, to answer that question, well, actually, you can't answer that question. If you're the transport developer, you don't know the answer to that question, because you don't. The values of the community are internal to the community. The business case of the airport is internal to the airport. They need to answer that question themselves. You need to help them, okay? But they need to run their own numbers on it and do their own thinking about it and have their own buy-in. And again, they're not really going to care about a lot of what you as a transport innovator care about, right? The capacity of the system, whatever. They'll assume it has the capacity, it just needs to work. But if they're a hotel operator, they care about how many rooms they book. If they're a retailer, they care about how many feet come in their door. Those are the metrics that matter to them, and they need to be able to do those calculations themselves. So whatever simulations you're running to help them do those calculations, they need to access those simulations. They need to be able to talk to them bidirectionally. And again, the policymakers need to see that they have all of this buy-in. Now, up at the top of this pyramid, you have this thing, actualization. And this comes from the original Maslow's hierarchy. And what is actualization? Well, it's sort of the pinnacle of this hierarchy of needs. If you've satisfied everything else, then you can move on to transcendence, enlightenment, etc. The bottom line is most people really don't care about that. And this is one of the big conflicts that I think we have internally as innovators, is most of the people who want to do some sort of disruptive, radical innovation, they do it for, as the gentleman was saying this morning, they do it for the vision. They start with the vision. And that really matters. Like myself, I have this vision for car-free cities. I'd love to be able to implement those. We need transport systems that would support the development of urban planning that can do that. Most people don't care. They want to get on with their lives. They'll never care. Me trying to convince them of my vision is only going to turn them off. So the challenge that we have is to not try to convince everybody that our newfangled innovation, which we can demonstrate with these simulations that resemble the light cycle races from Tron, is the best thing in the universe. We need to convince them that it will make their lives better in terms that they care about, not terms that we care about. So I would sort of encourage people to actually not push this too hard. Now, what this all adds up to is that other 50% of this budget, this $1.5 billion, was going to satisfy those tiers of the pyramid. Okay, it's not about building infrastructure, it's about meeting the needs of the community, and that comes through right-of-way acquisitions, which, yeah, you need to do, park and ride systems, multi-purpose bridges, road improvements, cycle path improvements, pedestrian improvements, public realm uplift in general, landscaping, parks, public art, and a really intensive stakeholder engagement process. Do you actually need to spend $60 million per kilometer on this? Probably not, but you do need to pay a lot of attention to it. Because that's not just a cost of the project, that's a benefit of the project. People care about that. That's how you get the buy-in. So a lot of what I see from transport innovators is very focused on optimizing that 30% of the project and making it cheaper and better and so forth. But most of what the public cares about is this. So, where does this leave us with modeling and simulation? Well, it does have a role, of course, but to the extent that it's physically accurate, that it's visually accurate, that it's easily communicated, that it's accessible to expert stakeholders on their terms and their file formats with their APIs, that it's accessible to non-expert stakeholders through things like gamified 4D interfaces and so forth. You need to be able to talk to all of these people in their languages, and they need to be able to talk to you also in their languages. It's a bit biased, but that's how it works. And it really needs to help everyone come to grips with the externalities, with the not the internal business case of the project, but how it affects all the other business cases that are proximate to it. And most importantly, this needs to be part of an iterative, collaborative process. You can't come down from on high with some amazing simulation that just convinces everybody that it's correct. They need to feel like they've been heard. They need to see their fingers in the pie. So you don't do this. This is not how you build a project. How you build a project is a lot more like this. It's a process of going through planning, engineering, simulation, visualization, engagement, feedback, back to planning again, and so forth. And eventually it spirals in and you might be able to actually build something. Now, the traditional way to do this is to spend 5 or 10 or 20 years in feasibility studies. If you're less patient than that, we're starting to get new sorts of digital collaboration tools that can hopefully make the process faster and better. So this is the point where I flog my own venture, Podaris. So it's a web application that provides reasonably physically accurate parametric planning, online with real-time multi-user collaboration with both an expert mode to allow planners and engineers and systems vendors and so forth to work with each other, and a non-expert mode that allows public stakeholders to drop pins on a map and tell you what they think. There's other tools like Krister's for Dialogue, which then provides much more immersive simulation and visualization and feedback, which is also extremely valuable. And as an example of how that could be used, we had our gentleman from Africa. He surprised everybody yesterday with a PRT system at the University of Pretoria, and I thought, what the heck? Let's leverage that. Sketch out a network. Yeah, I think that's the network you had on the screen there. It looks good. Let's deal with the site-specific constraints. So we can drop into the map, see how many trees we take out, see exactly where the stations can be placed and what the turning radiuses are and what the speeds are and everything else. Do some high-order calculations of sort of travel time and so forth. And this is actually pretty accurate. Share it with key stakeholders, which were a few other people in this room, and now we're ready to iterate the process and refine this and get a network that everybody can agree is the one we need to build. That took 15 minutes. So in a traditional process for doing this, it might take several months. So that is what I do. Thank you very much. Any questions?